Hello all, in this video I will discuss about infrared spectroscopy theory, instrumentation of infrared spectroscopy and sample handling techniques in infrared spectroscopy. I will try to cover in the next video. So main theory behind IR spectroscopy. So when IR light falls on the sample, some amount of the light is transmitted through the sample and some amount of the light is absorbed by the sample. So the absorbed light causes changes in the vibrational and rotational energy levels of the sample. So these changes in the energy levels causes absorption bands. The absorption bands give information about the different functional groups present in the molecule. This is IR spectrum. Here transmittance is taken on y-axis and wave number is taken on the x-axis. These are the absorption band. Absorption band looks like this. The absorption bands are classified into three types: strong, medium, and weak, depending on the intensity. IR spectrum is divided into three regions. Near IR region, it extends from 0.8 micrometers to 2.5 micrometers. This is the wavelength range for the near IR region. For mid IR region, the wavelength range is 2.5 to 50. And for IR region, wavelength range is 50 to 1000 micrometers. So you can calculate the wave number from the wavelength by using this formula. Wave number is equal to 1 divided by wavelength. So as we discussed earlier, the principle of IR spectroscopy. So when IR light is applied on the sample, if the applied frequency is equal to the natural frequency, absorption of the IR radiation takes place. So after absorption of the IR light, molecules are excited to higher energy state from the ground state. So due to this absorption of the IR light, it results in the vibration of the molecules. So this vibration causes the absorption bands. These bands are correspond to the different functional groups. We'll discuss in detail in the next slides. Criteria for a compound to absorb IR light. So to show the IR absorption, there are two criteria. First criterion is correct wavelength of the incident radiation. IR light is absorbed by the sample molecule only when the frequency of the incident radiation is equal to the natural frequency of the vibration of part of the molecule. Second requirement is when IR light falls on the molecule or sample, the IR light should cause change in the dipole moment. Then only IR spectrum can be seen. So there are two types of the molecular vibrations in IR spectroscopy. One is stretching vibration, second is bending vibration. So in stretching vibration, there is change in the bond length without change in the bond angle. There are two types of stretching vibrations. One is symmetric stretching, second is asymmetric stretching. In symmetric stretching, the atoms of the molecule either move away or towards the central atom. You can see these two atoms are moving away from the central atom or they move towards the central atom, both. In asymmetric stretching, one atom approaches the central atom and the other atom moves away from the central atom. This is asymmetric stretching. This is symmetric stretching. So in stretching, there is only change in the bond length. Next type of vibrations are bending vibrations. So bending vibrations are two types: in plane bending and out of plane bending. In bending vibration, there is change in the bond angle and bond axis. In plane vibration, in plane bending, here the bending of atoms occurs where the atoms swing back and forth with respect to the center atom. You can see the rocking vibration. These two atoms are moving like right direction or they move towards left direction. So this is rocking. In scissoring, um, here, they approach each other. The two atoms approach the central atom. This is scissoring vibration. Next, in wagging and twisting, In vacuum, what happens? The two atoms oscillate up. These two atoms oscillate up when compared to the central atom, or they oscillate down when compared to the central atom. That is vacuum. And twisting, one atom moves up the plane while other atom moves down the plane. This is twisting. Here both atoms moves either in upward direction or in the downward plane. Here one atom moves in the upward plane and other atom moves in the downward plane. This is like similar to twisting. This is called twisting vibration. IR spectrum is divided into two regions. First region is wave number range for the first region is 4000 to 1500 centimeter inverse. Here there are absorption bands of vibration states of various types of bonds. So these functional groups show the absorption bands in this region. NH, OH, C double bond O, C double bond C, C double bond N. These are the different bonds present in the organic compounds which show the absorption bands in this region. The table will be given in the next slide. So this is an example of IR spectrum. The molecule name is 1-butanol. You can see CH stretch like at around 2800 900 wavelength wave number range, and OH stretch is observed here. OH stretch, CH stretch, and CO stretch. CO stretch is observed here. So the molecule is 1-butanol. So the region till 1500, 4000 to 1500, this is this region in which you can see the absorption bands due to different functional groups. And the region below 1500 is known as the fingerprint region. So these are the wave number values corresponding to the absorption bands of different functional groups. The sharp band around 2200 to 2400 would indicate the possible presence of C triple bonds N or C triple bond C. C triple bond C, C triple bond N absorption band is observed in this range. And if you practice some spectra, you can remember these values. The absorption band for the different bonds like NH, OH, CH lies in this range. And absorption bands due to C triple bond, C double bond C, C double bond O can be seen in this range. Fingerprint region below 1500. You can see the absorption bands due to CC, CO, and CN. These are the values for different stretching vibrations and bending vibrations. Few examples I'll give. OH stretching in alcohols is seen at around 3550. Carboxylic acid OH stretch 3550. Amines NH stretch is seen at 3450. Nitriles and alkyne C triple bond C, C triple bond N, C triple bond C stretching can be seen at the wave number values of 2280, 2260. Second region in the eye spectrum is fingerprint region. So this region accounts for the absorption bands characteristic of the functional groups. So the region present below 1500 centimeter inverse shows absorption bands due to bending vibrations and stretching vibrations of CC, CO, CN bonds. So different regions in the fingerprint region again. First region 1500 to 1350. So if there is tertiary butyl group in the compound, double peaks are observed at 1380 and 1365. So if double peak is observed in the IR spectrum, it indicates the presence of the tertiary butyl group in the particular compound. Similarly, the stretching bands due to CO stretching bands in different molecules are like this. CO stretching of ethers can be seen at 1150 to 1070. CO stretching in case of primary alcohols can be seen at 1350 to 1260. esters, phenols, etc. Less than 1000 centimeter inverse. So if the absorption band lies in the range 750 to 700, it indicates the presence of monosubstituted benzene. And the air spectrum, one more application is geometrical isomers also can be distinguished. Geometrical isomers of olefins can be distinguished. So cis isomer shows absorption band at 700 and trans isomer shows absorption band at 970 to 960 range. Thank you.